So we're going to spend the next 5 minutes or so looking at a product called Autodesk Vault. Now Autodesk Vault is a data management tool. It comes in a few different flavours, mainly Vault Basic, which is the free version, so to speak, and it's something that you guys have pretty much all got access to if you have an Autodesk product. It kind of comes with most of them now. You then have paid for Vault, such as Vault Professional, which gives you further functionality. So Vault Basic gives you essentially just a data management system that manages and stores your data, and it kind of gives you one step above storing your data on a network share. What Vault Professional does is it takes all of those data management features and starts interlacing them and tying them into your business processes. As we're going to be using this throughout the demonstration today, what we wanted to do is just give you a brief insight as to what it does first. It's going to be a very quick overview, so I would recommend, if it's something that you think that could be useful for us, or this is something that I want to see more of, drop us an email or give us a phone call, and we can arrange either to have a chat with you over the phone, come in and see you, or we'll put on another webinar a little bit later on in the year. So I'm inside Inventor. All I'm going to do is go to my Vault tab, and you'll see that I'm logged in to my Autodesk Vault. I've got a very, very basic part, just a square, a cube, and all I'm going to do is I'm going to say I want to check that into the Vault. It's telling me I need to save this part first. So I'm going to say yes, I want to save it. You'll notice that I'm working on a local hard drive. Okay. I'm just going to create a new folder, just call it test. Go in here and I'm just going to save this file. Nothing different to what I do normally when I save a file on Inventor. I'm just going to give this some comments. So I'm just going to say initial check-in. I'm going to say that I want to close my files and delete a working copy. If I press OK, what this does is it uploads those files to Autodesk Vault, which is on my server. I'm just going to drop into the Vault client now and log in. So this is just logging in through a separate interface. It looks very much like Microsoft Outlook. So I've got folder structure on the left hand side, and on the right hand side I have previews. So we can see our box here, our part is checked into the Vault, and we can start seeing some information specific to this part. What I'm going to do is just drop back to Inventor, and I'm just going to choose to open. But rather than use the standard open, I'm going to say that I want to open directly from Vault. I'm going to browse to where I've stored that file. You'll note there is a search on the left hand side. It's quite a comprehensive search. So if you've got quite a complex file structure, you can search very quickly for your parts. I'm just going to double click that file, and I'm going to say yes, I would like to check that out. I'm just going to say I'm going to check it out for edit, and just say yes to update the properties. Because I've checked that out, I'm allowed to edit it. If I didn't check that out during the open process, the file would be locked as read-only, and I wouldn't physically be able to edit it. It's also worth noting that while that file is checked out to me, anyone else who's using this specific Vault, so for example James is set up on this Vault, if he tried to access that file while I'm using it, he wouldn't be able to, because I have the file checked out. So it's starting to give you very, very high level security, which is very good. It stops you getting issues as you design. So all I'm going to do is just add a hole through the centre of this square. So let's just add a 10mm circle on the top face and just literally extrude that all the way through the part. So we've just got a hole through the middle. I simply just want to save this now and check it straight back into my Vault. I'm just going to add some comments. Again, good discipline, best practice. Say that you want to link the 2D file, and that now gets checked back into my Vault. So if I come back into Vault and just do a little refresh, that refreshes the file for me. Okay, so you can now see that I have a hole through the middle. If I go to the right hand side and just say show all versions, it starts showing you the history of your file. So it started off as a box, initial check-in by myself. It then went on to have a box and a hole. The comments next to that, check-in after edit, added hole. So you can start to get quite powerful feedback from Vault. If I go to preview, you'll notice I have two previews. I can double click any one of these and it will open up a DWF of this 3D model that we can have a look around. Does the same thing for 2D DWGs or IDWs as well, so your drawings work in the same way. What I'm going to do now is I'm going to change the category that this file sits in. I'm just going to tell Vault that it's an engineering file. Now you can set Vault up to do this automatically based on some rules. I haven't in this case, so I've just literally changed the category. Because I've done that, if I just say show all versions again, you'll notice that it gives you yet another version. So everything you start doing in the Vault starts getting stored as a version, which is very important from a procedure point of view. Even if you're looking at things like ISO accreditation, everything starts getting stored as a separate version. Because this is now an engineering file, it's linked to a life cycle within the company. So for example, let's just change the state. You'll notice that it's currently work in progress, so it's a file that is being designed and it can actively be worked on by a designer such as myself. If I change that now to be for review and click OK, A, it gives me another version because it goes up a version, obviously. B, if I try and check that out now, it opens the file. Let's just put a little box on the side. And let's just save that and check that back in. Add some comments. When I check that back into the Vault, you'll notice that it still stays for review, but it's letting me edit that file. However, if I try and change the state to the next step, say I want to release this to manufacturing, you'll notice that I can't do it. So if we just log out of here and just log back in as James. So when I'm logged in as James, I have further permissions. So in this case, I can take this file and I can say that I want to release it. So I want to release as manufacturing. Once that's released, you'll notice that you get a padlock next to it. That padlock means you can't physically do anything with this file. It's now locked. So if I try and check it out to be able to edit it, let's just say that we want to check out all files related to that box. You'll notice that it doesn't actually do anything. So if I do a couple of refreshes, it doesn't physically check the file out because you can't edit it. It's released to manufacturing. If I change the state, let's say that we need to be able to edit it, so let's change it back to for review, work in progress. Click OK. That goes back to work in progress, but as well as that, it bumps the revision. So now we're working on revision B. And it's doing all those things that as a business you do anyway, but it's kind of doing it automatically for you in the background. So that's kind of a really brief overview of Autodesk Vault. I think I've taken a little bit more than 5 minutes, but hopefully that gives you an idea of what the software is and how it works. So when we start using it and talking about it throughout today, you should have an idea of what we're going on about. Again, if it's something that interests you, please let us know and we can take these discussions further. So many of you are working with colleagues or even with partners or customers that are still using 2D. So what can you do in this instance? So I'm in AutoCAD here, AutoCAD 2014, and I've received some files from a manufacturer of a robot assembly. So I've got pretty much all of the files for this robot apart from one piece or one part. For this they've only sent it in 2D for whatever reason. But it's actually missing some data, it's actually missing some holes around here. So we've kind of got everything that we need from this to be able to create a 3D model in Inventor, which James is going to go through in a second. But I want to show you how you can maybe prepare the model to get to that state. So first of all, we just want to check just to make sure that these are polylines. So in my case, everything is, apart from that section at the top, but that's fine. So wherever we've got a closed loop, we kind of want a polyline. We need that to be a complete closed loop so that Inventor recognizes it as a closed loop. In that case, I'm fine here. What I'm going to do is just add a little bit of geometry on. So let's just go in here and let's just add some holes. So let's just draw a line just for reference there, and I'm just going to draw a circle. Make sure my snaps is going to snap to the midpoint of that line. And let's just say that we want a 10mm hole through there, and let's just pattern that hole using polar array around that point, and I'm just going to say I want 6 of them. I'm going to do exactly the same thing down the bottom. What I might just do is do a copy with base point. So let's just do clipboard, copy with base point, select my base point, right click, go to clipboard and paste. I'm just going to paste that down to the bottom. So we've added our holes. So I'm quite happy with that. So what I'm going to do is save it. What I need to do is get this into my vault. So because we're using vault throughout the project, as we've already mentioned, I need to put this file into the vault along with all the other files from the robot, so when this gets sent to James, who's going to do some designing in Inventor, he knows exactly what to do with all of it. So I'm just going to choose to save as, and I'm going to want to put this in a location. Actually, to be fair, rather than doing that, let's just drop back to Windows Explorer. So this is my local Vault workspace. This is the files that I've received from the customer. What I'm going to do is I'm just going to take that name and create a new folder in this location. Once I'm in there, I'm just going to literally take all the files and paste them in. So now we've got a copy. Let's just hit save on there to make sure it's saved, and just make sure that's the latest version that is put over there. Let's just do a copy and replace. So I'm just going to open that correct version up in AutoCAD. So now we're working off our Vault workspace. So all I've done there is copied from a desktop, or it could be a zipped file, or somewhere that's completely outside of Vault. I've copied the file to my local Vault workspace. Now that I've done that, I can literally choose to log into my Vault if I'm not already. In this case I am. And I can choose to check this file in. Let's just give it some comments. Initial check-in. I'm just going to say that that's fine. Click OK. It's just asking me that it needs to save it one more time. So that's just going to go away and check that into the Vault, create the visualization files, the DWFs like it does normally, and that will eventually finish like so. So now that's done, I'm just going to drop into Inventor. Let's just open up Inventor, and I just want to open every single one of those parts, save it, make sure it looks correct, and then drop it into the Vault so that when James comes to work on it in a second, he knows exactly what he's doing. So for ease of use, I'm going to drop back to this folder in Windows Explorer, make sure I'm working on the Vault workspace version, which I am. Select every single one of those parts. I'm just going to drag them into Inventor just so it opens them all up. Like so. That'll just take a couple of seconds as I've chose to open more than one at a time. Once they're all in, all I'm going to do is just literally go to the Vault, log myself in, and just one by one go through and check in all of these files. So let's choose to check in. Let's just give it a comment. Again, you don't have to, but it is good practice. Let's just go in and say check in, and we're just going to do that on every single one. Once that's done, we'll be able to go back into the Vault client, and then these will be ready for the next step. The last two, go to Vault, check them in, add the comments, and finally the last one, check that in, add any comments. We go to our Vault client now, just to make sure they're all in there in the correct place. We can see that we've got our robot folder. You can see that we have all of our Inventor parts ready to go, and we have the 2D robot arm ready to be converted into 3D.
Now that Robin has created the 2D part, I'm now going to create the 3D part with an Inventor. So I'm just going to log in as myself, which will take me straight into the Vault environment. So if I open up here, you can see you have exactly the same functionality as you had in AutoCAD. So if I go into my engineering, 2010, and go down to the robot, we can see this 2D file that Robin's created for us. So what I'm going to do is I'm going to select it, but I'm just going to focus on this options part here. So if I open up here, I'm going to import the part because I want the 2D to come in a specific format into my 3D environment. So if I hit OK, I'm now going to check that out, and I'm just going to add some 3D creation to this and update all of the properties. So I'll say yes to all, and you'll notice I'm into my DWG DXF file wizard. So this is the process that allows me to import my 2D data into a manageable format. So if I select next, so what it's going to do now is it's going to process that file for me and show how it looks in 2D. So as you can notice, I can zoom in, I can interrogate it, and you can see the layers that have come in. So where Robin's added the holes and created the side view, I'm going to bring that into my environment. So if I hit next, it brings me up with a series of import options. So you can see here I can bring it in as a surface or a wire. I've actually predefined this as detected as millimeters. I've selected that it constrains the endpoints. So this is very important. If it's not constrained, when you start moving things around, they may fall out of position. I've also selected destination for this 2D data. So I've actually selected it as a new part and projected to a 2D wire sketches. So once I'm happy with this, I can select finish. And what this is now going to do is just going to bring it in. So you can see here, it's brought it in, and I've got 3 different sketches here. So I'm going to turn off the holes so I can put those on later. And I'm going to turn off this part as well. And I'm actually going to create this within the other part so we can delete that afterwards. So now if I open up this, come into my sketch, you'll notice everything's locked in position. I'm actually going to pull this and I'm going to copy it. So if I finish that, I'm now going to add a plane. So if I put up my origin, so what I'm going to create, if I use my centers there, I'm going to create an intersection. So these two 3D parts are intersected and create the one single 3D part. So now if I select the plane, select a new sketch, I'm going to quickly project the geometry here first of all, just so I've got an endpoint. I'm going to right click OK, and then I'm going to paste that part. So you'll notice the part that I took in earlier is now here. So if I pull that across, I'm going to use my rotate tool. I'm just going to select here. You could specify it, but it tends to lock into position anyway. And I'm now going to pull that across, and again use my move tool, specify my input, and I'm just going to put that in position. If you remember, I was going to delete the visible ISO layer, so I'm just going to pull that in, and again if I pull this across, use my intelligent dimension, so if I put a dimension here, so I can add it in like that. That's okay. I'm just going to put a dimension here. Okay, so now if I just double click that, just to ensure that they're exactly the same, so we can now know that they're in. And again, use the heads up display and close that off. Oh, just delete that. Just going to use the trim tool now to trim those parts that I've just created off, just so it intersects correctly and the correct areas are selected. So if I finish that, now I'm just going to go back to my sketch and delete that as we no longer need it. Finish the sketch. Now if I extrude this, at the moment I don't need to be particularly fussy with this, so I'm just going to use the controls to pull that out. And again, now the difference is I'm going to extrude again this part, but this time I'm going to use the intersect tool, and you'll notice that's created that 3D part for me. I can hit OK, and I've now got my fully created part. Let's turn off the visibility of that, and we'll bring it back into position. We can now go back and we can actually turn on those holes. So if I just turn on the visibility, I'm going to change the view slightly just so I can see before I extrude. And if I cut these holes, just to add the holes that Robin created earlier. Again, you could have done this in the Inventor environment, but sometimes it's just as easy if you've received those parts, so use them. So we just select the cut tool, hit OK, and now if I go back to my shaded view, you can see those holes are now in position. I'm just going to go on and add some material. So we can call this stainless steel. I'm just going to change the colour to a smooth yellow, so it fits in with the rest of the machinery. And now we have our part completed from 2D. I can now save this. So I can save this as new robot part. Just going to save that correctly. And now if we go and check it in, this is now ready to be added to an assembly.
So now that James has created that part in 3D, I'm just going to log myself into the vault, and this time we want to put that assembly together. So let's choose to create a standard assembly, just like you would usually do if you were working in Inventor, but rather than using the standard place to place from my hard drive, I choose to place from vault. This allows me to interrogate the vault and grab files directly from the vault and place them into a new assembly. So let's just go through and select the parts that I need in order to do this. Now you'll notice when I'm putting this together, this is quite a basic representation of a robot. It's not a fully detailed version, but for this example it's absolutely fine. So let's just ground the base here, just so it doesn't move. Once the base is grounded, we can just start adding some constraints. So let's just add an insert constraint here and here, or sorry, a center point mate or a center line mate to align them up, like so. And let's do exactly the same thing for this arm here against there, and again just drag that away and then constrain the face as a mate to the other face, like so. So this is starting to take shape. So let's start putting the top half of this together. So again, using the center line mate, I can make a spherical edge with another spherical edge, like so. And then I just need to simply say this face to this face, and that locks that into position. Let's do the same thing again to match those center points up. And now that that's on, we want to do a face-to-face mate using this face against this face. Let's give it, say, a 1.5mm offset. That's probably too much. So let's just have a little look at that and just change that down to 1. Absolutely fine. So we've got a 1 sort of degree of freedom left in there, but that's not something that we need to worry about at the minute. Finally, let's take a center line constraint and constrain up to this point here. Hit apply, or OK, sorry, and then we can just go in and face-to-face mate. Try that again. So now that's top half and bottom half fully constrained, all I need to do now is just connect the two together. So let's once again just use constrain tool, go around and select the two components that you want to constrain together, and then finally once more I'm just going to do another face to face. Obviously I've made a little bit of a mistake there. I've put them on the wrong side. That's not a problem. So just like with everything else inside of Inventor, we can just select the component that we've made the mistake on, find the two mates that are the problem. In this instance, I've obviously mated the wrong face to the wrong face. The center line stays the same. So for that second mate, I can right click and edit, select face 1, like so, click OK, and then that updates as such. So now that robot's fully constrained, obviously you've got some degrees of freedom in there so the robot can move as you would expect, but other than that it's ready to go. I'm just going to save it. When I save it I'm just going to make sure that I put it in the correct folder. So we're obviously on our local Vault workspace, so I just browse to where this should be. Let's just call it Robot SA or Robot Assembly. Hit save. Click yes to all, click OK. Click OK once more. That's just going to go and save that away locally on my hard drive, and obviously from there I can select Vault, click check in, and check those files into the Vault. Once those files are all checked in, I could go in and create a drawing of that now if I want to. In this instance, we don't need to create the drawing, and that will be done later on.
Has created the robot. I'm now going to log back in to the Vault, and I'm going to check out the main assembly. So I'm going to go through the same process as we have previously, and I'm going to open up the main assembly. The main assembly is 360 components, so it's quite a sizable assembly. We're then going to place the robot that's just been created and put it into the correct position so we can create the correct size frame for it. So as you can see, here's a complete assembly so far. We're now going to place from Vault a component. So we're going to go the same functionality as we have done before, go into engineering and find the robot that Robin's just created and open that up. You'll see here it's brought up an axis prior to putting the component in position. This is new functionality in 2014 where you can select the right axis prior to dropping it. So you can see here, I've just moved that around. I can now place it like so. Previously you'd have to place it and then go back and change the axis. So it could be quite time consuming. So this is one of the improvements for 2014. So now I'm just going to move that around, rotate it, and just check that it's roughly in the right place. So I'm happy with that. I now just want to constrain it. So I'm just going to constrain that to the main model. The reason for that is I want the height to be exactly right. So if I apply this, and I'm going to move this out slightly. So we just put that in position. I'm going to use the inspect tool just to get the correct height of the unit. so we know it matches the main frame, and I'm going to copy that and use that shortly. So now what I want to do is I want to create a new assembly so that I can create this frame. So if I open this up, go back to assembly and hit create, so I can create a new part within an assembly, so I can reference dimensions and details. I'm going to call this frame. We'll call that new robot. And you see that's going into the default Vault workspace. I'm going to select that, so you can see now on the feature tree this robot assembly has been created. And now I want to create a part within my new assembly. So you can see here it's come up as standard part. We'll call this frame. And I'm going to select the bottom face. So the reason for this is I want to use the adaptive technology within Inventor, so that I can ensure all of my frames and details are all referenced correctly. So I'm going to select this as a sketch. I'm just going to project the geometry. So I've got the outside dimensions. So that if this does change, it actually changes my frame as well, so I can ensure that I'm always correct. Finish that. And I'm just going to turn off now some of my work features so you can see. You can see there at the bottom the sketch lines that I've just created for the frame. So I'm going to now return, get to the top level, return again. I now don't want to be in this because it's quite a cumbersome model. I don't want to throw it or slow my performance down, so I'm just going to open up my robot assembly. Sorry, my new frame assembly. And you can see I've got that part that I created. Again, I'm going to open that up because I quickly want to create an extrude for this. So I'm going to use a surface, but after I'm just going to edit that quickly. So by creating a reference, I'm adding on some of the functionality. So I'm just going to finish that sketch. And now I'm going to use the extrude, and I'm going to select the functionality that way. So I'm just going to move that down. If you remember, we took the dimension of 679. So click OK. I can go back now to my main model. So you can see that's actually gone the wrong way. So what I can do now is go back, edit that surface, and we can put it back the other way. So now if I hit OK, my main model's in the correct position. So now I've done that, I want to go back to my assembly where I can use the design accelerators. So if I go up into here, just check for updates and go into the design. So the design functionality here gives you some design accelerators. So you've got various things like bolted connections, frames, miters, shaft generators and gears. I'm only going to use the frame, and then I'm going to use some simulation afterwards. So if I insert a frame, it prompts me to save. I can now select all of the different edges. So you can see here I've got different standards, I've got different types. So I can go for circular, I can go for hot rolled. There's various different types there, and I can also use the rectangular. Select some sizes. So if I go down, let's choose this size, and we'll keep it as mild steel. If I select the edges, you can see how it gives me a preview of how this will look. Frame-wise. And I can again go back and change the size. So if I pull this down, I can bring it down slightly. And I can bring it down even further size. So at any point I can go back and edit this design accelerator. So if I apply this now, you can see here it's going to store it separately, and it's going to show me all of the components I have in this assembly. So once I've done this, it's now creating it, it's adding it to that referenced surface that I've created, and I'm finished with that now. I can now go back to my main model, and you can see instantly it's updated, so I know it's all in position, I know it fits. And go back to my frame, and I can start adding things like mitres onto it to tidy it up and ensure it all looks correct. Cancel that. I'm just going to add some mitres onto the bottom here to ensure it looks okay. If I wanted to add any additional supports later on, then I could. But that's now my rough frame. I just want to check that it's fit for purpose. So I can quickly do this early on in the design. So I've taken that, it's taken me a couple of minutes to create. I can go into frame analysis now and start a quick simulation. I'm going to use a static analysis for this. So I just want to see whether it will hold the weight that my robot is. So I'm just going to ensure that my gravity, so you can see there I've got gravity selected. It's actually in the wrong position. So if I edit that and drop that down, you can see it's now in the correct position. I'm going to put a few fixed features on it. So fix it in position, like so. Just going to fix these joints. Oops, zoom in like that. Like so. And I now want to add some force. So I'm just going to add some force here. So I'm going to call this, let's call that 250, just to make sure it's evenly distributed. I can now actually add, so perhaps I should add a continuous. So if I just delete that, I can go onto here and add a 250 continuous loading. I can do this for each side. So to check that these beams are correct. And that one's actually changed slightly, so I could go back, and again, the nice thing of this is just delete them if they're not there, and go back and put the correct one in. So I can put that as 250, and again, yeah, okay. So we've now created our simulation, got a rough idea, we just want to see if this is going to work. So I can hit solve. This is now going to start up the calculation and solver. So you can see here it's got a few stresses on the frame. There's 2 mil of displacement, which is not too bad depending on the thing. So if we look at actual, we can quickly see that that's not too bad, and we've got some areas of constraints we could actually probably do with later on changing that, or I could go back and change it now, but for the time being I'm fairly sure that 2 mil is not going to cause too much of a problem. We can actually animate this at any time, so I could quickly get a quick visual. So if you wanted to take this to your boss in order to say, right, this needs to be changed, this is my reasoning behind it, you could quickly do so. You can also export different drawings and probe out any areas. So if we wanted to see that red area, for instance, we could hit the probe and pull that out. So you can see here, you can look at different parts. So now that I've done that, I can save that. That's all going to save in the model. I can go back to my main model here. So if I just go back to my frame, I'm going to hide that so we don't see that in the model. Turn off the visibility there also. Close that down. And also close this part down. So we can now go back in to the main model, and we can check that in. Now we've created our main frame. So I can go back, check for updates, go back to my vault, check it all in, check that it's all been saved. That's now all going in, so call that frame check in. hit OK. Now that that's all checked in, we're ready to move on to the next part. Make sure the links for the 2D is also linked, so everything goes in as it should, and that's now saved.
So this brings us on to our final product that we're going to look at today, and that's Autodesk Showcase. So a little bit of history behind Autodesk Showcase first of all. It comes from the automotive industry, and it used to retail at about £20,000 per license. Autodesk acquired and purchased this software a few years back now, about the same sort of time that they acquired the Alias software. And from that point onwards, they saw the use of this product and how their customers could use it, not just for automation, but for other industries as well. And they decided to make the price point a lot cheaper, in that a lot of you with design suites should now notice that this product comes as part of your suite package. So Showcase itself offers you the ability to produce very nice, realistic looking imagery very quickly and very easily. So we have our machine that we've modelled up inside Inventor that we've just imported into Showcase, and as you can see, the imagery itself is very, very good. We have a very nice image of the machinery, all coloured and materialed up. What Showcase allows you to do is produce this imagery very quickly, in that if I go to my alternatives, I have alternative lineups of this specific product. I've got one lineup where I can just literally change the colour of the machine from green to high-vis yellow to a blue, a very dark blue at that, but it is a blue. As well as that, we have the ability to change the view. So if I come out of alternative and go into my shots, I have the ability to look a front view, a left view, and even look at predefined videos. So this is just a nice zoom which zooms into a tool. So as you can see, the quality of the materials in Showcase and the quality of the lighting and the shading is pretty good. You know, it gives you a very realistic image. It's not going to be as good as a fully lit, fully rendered 3ds Max image. You'll kind of never beat that kind of result from 3ds Max if you put the time and the effort into it. But the result that you get from the time that you put in is second to none. Again, just playing one of the videos. This is just going to zoom in to all the pneumatics, all the hoses and connections on the back of this model. So where Showcase is really powerful is we've been looking at some preset views here, but we can actually just pick this thing up and rotate it just as if it was still inside Inventor. So what Showcase allows you to do is manipulate your 3D model while being completely fully rendered. We can rotate, pan, and zoom in and zoom out just like you would inside your design tool. And the way it works is you have a 3D HDR environment. That environment essentially picks up on not just the imagery of the environment, but also where the light is coming in through the windows, and therefore casting light and casting shadows on our product. By default, Showcase will import any materials that you specify inside of Inventor and put those materials on inside of Showcase. If we want to change them, it's very, very quick. So if I just select this yellow part here, just right click and say I want to select all objects with that yellow material. I'm going to press M for materials on the keyboard. Just go to Showcase Materials. Let's say we want to make it a nice car paint, and let's make it a metallic red. Once that's set, if I press A once more for alternatives, and in my lineup 2, I can literally just, with all of that selected, click Add Next Alternative. Now, as well as the blue, the high-vis yellow, and the green, we also have a red. It's that easy to add a material lineup inside of Autodesk Showcase. Let's just add one more. With those red objects selected, I can select objects of that type, come to the left-hand side, and select a material. With that material selected, we can literally come up and click Add Next Alternative. As long as those materials that you want to add to the alternative are selected, they will be added into the lineup. We can go around and do this for as many products or as many parts inside here as we want to. So we can go in and maybe give the frame a nice red powder coat, as well as perhaps go through, select the hoses, and maybe let's right click and select all of the hoses and make those into, let's just say, rubber. Actually, rather than do it as rubber, we'll just put them as a lacquer and just make them a nice yellow lacquer. So it's really quick to change everything. Select the whole lot, add a new alternative, and you have yet another material lineup. It's just added 2 there by accident, so let's just delete that duplicate. My mistake. Let's just try that again. Select all of the hoses, all objects of that type, set those to be a yellow lacquer, and as well as that, select the frame and select that to be a nice red colour.